Good morning, Chem Kids. Today we're going to be going over dilutions. This is the last lesson of this chapter, so we will be having some sort of a quiz probably the day after tomorrow. So to get into dilutions, we're going to talk about what the diluting process really looks like in a chem lab. We're going to talk about some of the different procedures of diluting something, including some of like the safety concerns, especially when dealing with acids. And then we're going to do some calculations involving concentrations of dilutions. So a dilution is essentially just any time you add water to any type of solution in order to lower its concentration or make it more dilute. The number of moles of the solute won't change. You will still have the same amount of the solute dissolved. It's just the volume of the overall solution that increases, which will then decrease the concentration. The concentration and the volume of the original solution and the diluted solution are related through this formula. Concentration of the initial times the volume of the initial equals the concentration of the final times the volume of the final. Another way that you'll often see this written is C1V1 equals C2V2. So when we're doing a dilution, usually whatever you start with is called the stock solution. And you usually know what its concentration is. That's like, you know, in the chemical supply lab that we have in Miss Ben's room, all of the bottles of solution that we have back there are stock solutions, and they would have their concentrations written on them. Then usually, as like a chemistry teacher or something, I would say I need a specific volume of a solution, and I need it at a more dilute concentration so that my students can work with it. And so we'll use that formula, C1V1 equals C2V2, to figure out how much of our stock solution we have to add to water in order to make it the right concentration. This is something that I do all the time when I'm preparing labs. So we'll go over an example of what this would look like. This is the type of calculation that I would do when I'm creating a solution for you guys to use. So it says I have a 6 molar solution of acid. So that would be our stock solution. That's what we're starting off with. I need 800 milliliters of a 0.5 molar solution. So I have to dilute this from 6 molars to 0.5 molar. How much of the stock solution will I need in order to make my desired solution? So I'm going to walk through how to do this, and then you guys have some practice questions. Okay, so this is what we're starting off with. We have our 6 molar solution. We need 800 milliliters of a 0.5 molar solution. So I'm going to start with my formula, C1V1 equals C2V2. Again, these could be I's for initial and F's for final, if you rather. Then I'm going to plug in my 6 molar. My halves are my initial concentrations and volumes, so I'll put my 6 there. I'm trying to figure out how much of this I'm going to need to use to make my desired solution. So that's what I'm searching for, is my V1. And then I plug in my C2 is 0.5, and my V2 is 800. Now, when you're doing these calculations, you can use milliliters. This is not like C equals N over V, where you have to use liters. Though if you would rather just always turn everything into liters to be on the safe side, you certainly can do that. But this is one of the formulas where you can use either liters or milliliters. Whatever units I plug in on this side must be the same on the other side. Okay, so now to solve for my V1, I just divide by 6, and then 0.5 times 800 divided by 6 is 66.6 repeating. So that is in milliliters. That is how much of my stock solution I will need. In order to figure out how much water I would need to add to this, I just take my desired volume of 800 milliliters. I subtract how much of that is going to be my stock solution, and then the remaining amount must be water. I would like you guys to try these dilution calculations now, so just pause the video, try these, and then I will show you the answers once you've had a chance to try them. Okay, so these are the answers for the questions on slide number 6. So the first question asked us to determine the volume of our stock solution and of water that we would need to use to make our desired solution. So once again, we're going to start with our C1V1 equals C2V2 formula. We're going to plug in the concentration of our stock solution, which is 3 molars. We're also going to plug in the concentration and the volume of our desired solution. And then in order to solve for the volume of our stock solution required, we just divide by 3 on both sides, and we get 56.6 repeating milliliters of stock solution required. Then, in order to figure out how much water we're going to need, we take our total volume of desired solution, subtract the amount of that that's going to be stock, and the rest of it will be water. Question number 2 works a little bit differently because instead of finding the volume of stock, we're given the volume of stock used and we're asked for the concentration of our new solution. So in our C1V1 equals C2V2 formula, we have our initial concentration, our 4 molar stock solution. We also know that when we make our desired solution, we are using 150 milliliters of the stock. So that's what goes in here. This is the 150 milliliters of stock solution that was used. We're trying to find our C2. And this is the one part that's a little tricky, is our V2. This is the volume of solution that we created. And in order to make that solution, we took 150 milliliters of stock plus 450 milliliters of water and made 600 milliliters of solution. So that's where the 600 comes from. And then in order to solve for the concentration of our new solution, we just divide by that 600 on both sides, and you end up with a 1 molar concentration. Okay, when we're diluting things, though, and when I'm making these kind of solutions for you guys to use, or any of my chemistry kids to use, we don't always have a liquid stock solution. Sometimes we have to make our own stock solution because the chemical that we have is in powder form or solid form. And so in that case, we won't have an initial concentration right away. We're actually going to have to take a step back from that and start by making our stock solution. In order to do that, we have to take the mass of the powder or solid that we're starting off with, convert it into moles, because we can't do very many calculations with mass. So we use our moles equals mass over molar mass to convert our mass of solid into moles. Once we have moles, as long as we have volume, we can then find our initial concentration and then go from there. So we're going to walk through one of those kind of problems together, and then again, you guys will practice it. Just so you guys know, when it comes to the test or quiz, this is the kind of dilution problem that you're more likely to see compared to the one that we just did. So be more familiar with this type. Okay, so for this problem, we were told that we had 104 grams of calcium chloride that we added to 2 liters of water in order to make our stock solution. It then said that we needed 300 milliliters of a 0.2 molar solution. It wants to know what volume of stock and water were required to do this. So when you're solving a problem like this, anytime I see mass in chemistry, my first thought is always to get it converted to moles, because moles is a much more useful unit of measurement in chemistry. In order to convert to moles, we have to start with a molar mass. Our very first step should just be writing out the formula of calcium chloride. So calcium is Ca, chlorine is Cl. But don't forget, anytime we have an ionic compound, we have to cross our charges. So calcium has a charge of 2, so that'll cross over there. Chlorine has a charge of -1, so we don't bother writing it in. Once we have that, now we can find the molar mass. So we just look at our periodic table. We're going to take the atomic mass of calcium, which you probably can't see because it's super blurry, but it says 40. And then chlorine is 35.45. And we'll take 2 of those chlorines because of that little 2 there. So if we add those all together, you get 110.9 as your molar mass of calcium chloride. Now that we have our molar mass, step 2, we'll be plugging it into our moles equals mass over molar mass formula. So our mass, we were given in the question, it's 104, divided by the molar mass we just calculated. And if you divide those, you should get 0.9378-ish moles of calcium chloride. Once I have moles, I can now plug it in to my C equals N over V formula, because right now I don't have the concentration of my initial stock solution. So that's what I'm looking for right now. So I'll plug in the moles that we just calculated and divide it by the volume of my initial stock solution, which does have to be in liters. Luckily, it already is. And that gives us 0.4689 molar as our concentration of our original stock solution. Now that I have that concentration, my next step is plugging it into my C1V1 equals C2V2 formula. So this is my concentration, 0.4689. I don't know my volume of stock solution that I need. A really common mistake here is plugging this 2 liters of stock solution into this V1. This 2 liters is how much stock solution we made. This is how much stock solution we have. V1 is how much stock solution we use, okay, which is something that we're being asked to find. So don't plug this 2 liters in our C1 and V1 equals C2 V2 formula. This 2 liters is only used to find the concentration of our stock solution. It's not how much stock solution we used. So V1 is what we're looking for. It's what we were asked to find. Then we plug in our C2 and our V2, this 0.2 and 300 milliliters. Again, in this formula, C equals N over V, our volume must be in liters. In this formula, it can be in liters or milliliters. So now I just divide in order to isolate my V1. And let's see what that is. That gives us 127.959 milliliters. Because I plugged it in milliliters, the answer comes out in milliliters. Okay, so that is how much of the stock solution we need. Last step, in order to figure out how much water we need, we take the total volume of our desired solution, just 300 milliliters, subtract the amount of that is going to be stock, and that'll give us 172-ish milliliters of water. Okay, and that's all we do. Okay, so please take the time now to try these two questions. Just pause here while you try them, and then I will give you the answers. Okay, so question number 1 on slide 8, we're going to start once again by writing out our formula for potassium sulfide. Don't forget to cross our charges. Sulfur has a charge of -2, that's why we have that little 2 there. And then we find the molar mass. We do that by finding the atomic mass of potassium, which is 39, and multiplying it by 2, since there's 2 of them, and then adding our atomic mass of sulfur, which is 32. And if we put that all together, we get a molar mass of 110. Step 2, we were given that we had 400 grams of potassium sulfide, which is not very useful to us, so we convert it into moles. Moles equals the mass of 400 grams divided by the molar mass we just solved for, and we get 3.63 repeating moles of potassium sulfide. We can then use that to find our concentration of our stock solution. So we take the moles that we just found divided by the volume. So C equals N over V. We had 0.5 liters of stock solution. That's how much we made. So if we do our moles divided by our volume, we get 7.27 molar, or moles per liter, as our concentration of stock solution. Our next step is to plug that into C1V1 equals C2V2. So we plug in the concentration of stock solution. Again, this is what we're looking for, how much stock solution was used, not how much we have, which is the 0.5 liters. So we're looking for our V1. We plug in our concentration and volume of our desired solution, and then we divide by 7.27 in order to solve for V1. So 0.9 times 3 divided by 7.27 gives us 0.37 liters.
Hi, Emily. Here's a call from July.
Okay, sorry for that interruption. I'm not sure exactly where I left off, but I think I was somewhere around here. So we plug in our concentration and volume that we were given for our desired solution. We plug in the concentration that we just found of our stock solution, and we solve for the volume of stock that we're going to use, which is 0.37 liters, or 370 milliliters. To find out how much water we're going to use, we take the volume of solution that we're creating, subtract the 0.37, that is going to be our stock solution, and we get 130 milliliters of water. Okay guys, I apologize profusely. I was using the numbers from the next question. So in this question, the concentration of our desired solution is actually 0.3 molar, and we are dealing with 80 milliliters of solution. So if we do 0.3 times 80 divided by 7.27, we get 3.3 milliliters of stock. So that's our answer, 3.3 milliliters of stock. Then to find how much water we're going to use, we take the 80 milliliters of desired solution minus the 3.3 that's going to be stock, and the rest, the 76.7 milliliters, will be water. The second question is a bit more complicated because this is the question where we are not given the concentration of our stock solution. Instead, we are asked to find the concentration of our stock solution. So we're looking for C1, and we're doing that so that we can eventually get the mass of the solute that was used to make our stock solution. Right now, we don't have enough information for that, but we do have enough information to plug things into our C1 times V1 equals C2 times V2 formula. So we're going to plug in our 50 milliliters of stock solution. We're also going to plug in our volume of desired solution. So this is the volume of the solution this is the concentration of the solution that we made. This is the volume of the solution that we made when we added the 50 milliliters of stock to 250 milliliters of water. Then in order to isolate C1, we divide by 50 on both sides, and we get that our C1 is 5.4 molar. Once we have that concentration, we can use C equals N over V to find moles. Anytime we're converting between moles and concentration, we can always use this formula. So we plug in our 5.4 molar, plug in our 3 liters, and then we just multiply by 3 in order to get 16.2 moles. So that is how many moles of solute were used to make our stock solution. Anytime we have moles, we can then convert to mass using moles equals mass over molar mass. We just have to find our molar mass first. So that's step 3 over here. We write out the formula for lithium sulfide. Don't forget to cross your charges. And then the molar mass is just the atomic mass of lithium times 2 plus the atomic mass of sulfur, which gives us 45.8. Then we plug in our moles, 16.2, and our molar mass into our moles equals mass over molar mass formula, multiply by 45.8, and that gets us 741.96 grams as our mass. So it's important when you're doing these questions, if you're not sure where to start, write out what variables you have. So for example, in number 2 here, we had volumes of both initial and final solutions, and we had a concentration of our desired solution. As soon as we see that we have that information, we know that we can plug it into our C1 V1 equals C2 V2 formula. So a lot of the time, if you don't know where to start, just figure out what variables you have and therefore what formulas you can use, okay? And then from there, always remember that you can always convert between moles and mass using moles equals mass over molar mass, and between concentration and moles using C equals N over V. Okay, let's move on to dilution safety. So when we're dealing with these stock solutions, they are usually really high concentrations, which can make them dangerous to use. So we've always got to have our PPE, our personal protective equipment, so gloves, glasses, sometimes aprons. You should also always be standing when you prepare these solutions. If you're sitting, there's a risk that you could dump the solution in your lap accidentally. So you are always supposed to be standing. So if you do drip it, the most it's going to get on is your shoes. Should also always be wearing closed-toed shoes in case that happens. You should also never be standing over your solution and looking down on it. It should be in front of you. So in case it like spurts up or something, or there's a gas that's produced, you don't want to be inhaling that. You should always use distilled water, not tap water, so that there's no unpredicted reactions that are taking place between stuff dissolved in tap water and your stock solution. And when you're diluting acids, you always add acid to water, not water to acid. That's important because when you mix acid and water together, it is an exothermic reaction, so it releases heat and it can cause bubbling and stuff like that. If you take your acid and you add water to it, you're adding water to a very concentrated acid, so that can be a very vigorous reaction and can actually explode. On the other hand, if you add the acid to the water, as the acid is getting poured into the water, it's getting diluted really, really quickly, and therefore it's not as dangerous. So always add acid to water. If it's not an acid, we actually usually do it the other way around. So first, we'll kind of follow the calculations that we just did to figure out how much stock solution and how much water is needed. Then you take a pipette, which is like the little bulb thing that you squish and it like pulls liquid up. You're gonna rinse that with some stock solution. Then you're going to pipette the stock solution into a flask, rinse the pipette with distilled water, add that to the flask, and then add however much more distilled water you need. And then you stopper the flask, so put like a little cork in it essentially, and then invert it to mix. You don't want to like shake it to mix it, you just gently invert to mix. If it's an acid, again, you still have to calculate how much of the acid and how much water you're going to need. But this time you're going to place the water in first. You'll place most of the water in. Then you'll use a pipette once again to transfer the solution. This time the acid is getting transferred into the water. And then you'll once again rinse the pipette with some distilled water. Add that rinsed water to your flask as well, and then any more water that's needed. Then you want to wait for it to cool down, because again, this is an exothermic process when you're mixing acids and water, so it will heat up the solution, and when things warm up, they expand. So wait for it to cool down. You might see that the volume drops a little bit when it cools down, so add a little bit more water, and then stopper and invert to mix again. Okay, when it comes to actually making our stock solutions, again, you do need to eventually end up with a very precise concentration. So if you have a solid solute, you will measure that out on a balance or a weigh scale of some sort, and then transfer that solute to a beaker. Then you add water to that, again, making sure that it's distilled water until you completely dissolve your solute. You can use a glass stir rod to stir that in if necessary. And then you pour it into a volumetric flask using a funnel, just for safety purposes. Then you have to rinse the beaker, the stir rod, and the funnel with distilled water, and all of that needs to end up in the flask. And then just add distilled water until you get the amount of volume that you are aiming for. And then once again, stopper, invert to mix. And that is all that you need to know about dilutions. The most important part of this lesson is definitely the calculations, so focus on that, and then know a little bit about the safety that comes along with dilutions.